The granite walls of Yosemite have stood for millions of years, towering above the valley floor, with an appearance so permanent that generations of visitors have treated them almost like monuments carved outside of time itself. Climbers have trusted those walls with their lives. Hikers have passed beneath them without hesitation. Photographers have framed them as symbols of stability, endurance, and geological calm. Yet on the western side of Royal Arches, one of Yosemite National Park's most recognizable granite formations, a widening fracture has begun, forcing officials to confront a reality that the Sierra Nevada has always quietly carried beneath its beauty. Even solid stone moves. How does a cliff face that appears immovable begin separating apart in plain sight? How can a crack only inches wide threaten thousands of tons of granite suspended hundreds of feet above a trail? And why are scientists and park managers paying such close attention to a fracture that many visitors might never notice from the valley floor? The answers lie inside the granite itself. The growing crack at Royal Arches did not appear out of nowhere. It did not emerge from volcanic unrest, earthquakes, or any mysterious geological anomaly. Instead, it represents something both ordinary and unsettling at the same time: the slow mechanical breakdown of one of the most famous rock landscapes on Earth. The fracture, located near the Superslide climbing route on the western side of Royal Arches in Yosemite National Park, first gained broader attention after climbers reported visible movement in the rock during the early part of the decade. By the time officials began examining the area more closely, the concern had shifted beyond routine cracking. Investigations indicated that a massive rock pillar had become partially detached from the cliff face and was continuing to move outward. That movement triggered closures in the area. Sections of climbing routes were shut down. A portion of trail beneath the formation was also closed because of the possibility that the fractured granite could eventually collapse in a rockfall event. At first glance, the dimensions of the crack sounded almost insignificant. Early reports indicated openings measuring roughly 1 inch, or about 2.5 centimeters in width. But by 2 years later, updated observations suggested portions of the fracture had widened to nearly 4 inches, or around 10 centimeters. In human terms, 4 inches may seem small. In geology, it can represent the difference between a stable formation and a detached mass approaching failure. Royal Arches itself rises dramatically above Yosemite Valley, forming part of the immense granite system that defines much of the park's central landscape. The formation sits near North Dome and Washington Column, in terrain shaped through millions of years of uplift, erosion, glaciation, and fracturing. Yosemite's granite cliffs were born deep underground when molten rock slowly cooled beneath ancient mountain systems. Over immense spans of time, erosion stripped away overlying layers, exposing the hardened granite now visible across the Sierra Nevada. That exposure created stresses within the rock. Granite formed under enormous pressure beneath Earth's surface. Once exposed at the surface, the reduction in pressure allows the rock to expand slightly. This process produces fractures known as sheeting joints or exfoliation cracks. Yosemite is famous for these features. Entire slabs of granite can peel away from cliffs in sheets resembling layers of onion skin, though the scales involved are vastly larger and more dangerous. The Royal Arches crack appears connected to these long-term natural processes. Water seeps into microscopic openings within the rock. During colder periods, freezing temperatures cause that water to expand. The expansion slowly forces fractures wider. Heat during warmer periods can also produce subtle expansion and contraction cycles inside the granite. Over decades and centuries, those repeated stresses gradually weaken sections of cliff faces. Gravity then does the rest. Yosemite has experienced countless rockfalls throughout recorded history. Some were relatively small, scattering debris onto trails below. Others were massive enough to reshape portions of the landscape. The park's towering cliffs continuously evolve through these events, even if the changes occur too slowly for most visitors to notice during a single trip. The Royal Arches fracture stands out because its movement is being directly observed while the rock mass remains attached. According to reports surrounding the monitoring effort, climbers initially detected indications that parts of the wall were no longer behaving like fully stable granite. Small shifts, unusual gaps, and visible separation lines raised concerns that a large pillar section had become isolated from the main cliff structure. Park officials eventually responded by restricting access to the affected area. The closures were not symbolic precautions. Yosemite's history contains repeated examples of rockfalls occurring with little warning. In some parts of the park, rockfall events have released thousands of cubic yards of granite in seconds. Blocks weighing hundreds or even thousands of tons can accelerate rapidly down cliffs, shattering into debris fields that spread across trails and forested slopes below. The danger does not come solely from direct impact. Air blasts generated by major rockfalls can flatten trees and scatter debris outward far beyond the initial collapse zone. Royal Arches occupies terrain frequented by hikers and climbers, making any instability especially concerning. The formation is widely known within the climbing community, with routes tracing complex lines across steep granite faces. The nearby trail system also attracts heavy foot traffic during peak visitation seasons. Yosemite National Park receives millions of visitors annually, particularly during warmer months when climbing and hiking conditions are favorable. Managing geological hazards in such an environment creates difficult challenges. Granite cliffs naturally fracture and shift over time. Yet predicting exactly when a detached section may collapse remains extraordinarily difficult. Some fractures remain stable for decades before failure occurs. Others accelerate unexpectedly. Measurements from the Royal Arches crack suggested continuing movement over the span between initial observations and later reports. An increase from approximately 1 inch to 4 inches may not sound dramatic on paper, but the widening implied that the detached pillar remained active rather than stabilizing. The significance lies not only in width, but in motion. A widening crack indicates ongoing deformation within the rock mass. That movement can result from gravity pulling the detached section outward, seasonal thermal expansion, water pressure inside fractures, or combinations of multiple factors acting simultaneously. In Yosemite, these processes are amplified by the park's environmental conditions. Summer temperatures can heat exposed granite surfaces intensely during daylight hours before cooling sharply overnight. Winter storms bring snow, ice, and moisture deep into fracture systems. Seasonal precipitation patterns influence groundwater infiltration inside cliff faces. Over long periods, these repeating cycles weaken bonds within the granite. Even tree roots contribute in some areas, exploiting tiny openings and gradually widening them as vegetation grows. Although Yosemite's cliffs appear rigid from a distance, detailed monitoring has shown that portions of the granite landscape undergo measurable movement. Researchers studying rockfall hazards in Yosemite over recent decades have documented exfoliation events involving slabs unexpectedly peeling away from cliffs. Some movements are so subtle they require specialized instruments to detect. Others become visible through widening cracks, like the one at Royal Arches. The park has increasingly relied on modern monitoring technologies to study these hazards. Laser scanning, crack meters, aerial mapping, and photogrammetry now allow officials to track changes in cliff geometry with far greater precision than was possible in earlier decades. Repeated scans can identify slight shifts in rock faces over time, helping determine whether a fracture appears stable or increasingly hazardous. At Royal Arches, the concern centered on the possibility that the partially detached pillar could eventually fail in a large rockfall event. That possibility forced closures beneath the affected area because Yosemite's steep terrain leaves little room for error. Rockfalls descending from hundreds of feet above can reach extraordinary speeds before impact. Trails passing beneath unstable cliffs effectively become exposure zones whenever movement accelerates. Visitors often underestimate how dynamic Yosemite's geology truly is because the landscape feels ancient and permanent. Yet the valley itself owes much of its appearance to violent geological processes operating over immense timescales. Glaciers once carved through the Sierra Nevada, deepening valleys and steepening cliff walls. As ice retreated, the newly exposed granite experienced pressure release and fracturing. Those fractures continue evolving today. Royal Arches forms part of this larger geological system. The cliff's immense curved surfaces reflect exfoliation processes that have shaped Yosemite's granite for thousands of years. Large sections periodically detach, collapse, and accumulate below as talus slopes. Fresh rock surfaces exposed after rockfalls often appear lighter in color before weathering darkens them over time. Some of Yosemite's most famous rockfall events dramatically altered sections of the park within moments. In previous decades, major collapses near Glacier Point and Curry Village demonstrated the destructive potential of unstable granite. Some events destroyed structures, damaged infrastructure, or injured visitors. Others sent dust clouds rising above the valley floor as thousands of tons of rock disintegrated during descent. These incidents reinforce the reality that Yosemite's cliffs are not frozen landscapes. They are active geological environments, still responding to erosion, stress redistribution, and environmental change. The Royal Arches fracture fits within that broader pattern rather than standing apart from it. There is no evidence linking the crack to volcanic activity beneath the Sierra Nevada. Despite occasional public speculation whenever dramatic geological changes appear in famous landscapes, Yosemite's granite fractures are well understood products of natural mechanical weathering and stress release. Exfoliation remains one of the dominant drivers. As granite expands after exposure near the surface, curved fractures form parallel to cliff faces. Over time, those fractures can isolate slabs and pillars from the main rock body. Gravity gradually exploits the weaknesses until failure eventually occurs. Water infiltration accelerates the process. Once moisture penetrates cracks, repeated freezing and thawing widen openings further. Even without freezing conditions, water can chemically alter minerals inside fractures, reducing cohesion between grains. Thermal expansion adds another layer of stress. Granite heats during daylight and cools at night, producing constant cycles of expansion and contraction. Across large cliff faces exposed to direct sunlight, these repeated changes contribute to gradual weakening. The Royal Arches crack appears to embody multiple overlapping processes occurring simultaneously. Climbers familiar with the area reportedly noticed not only widening gaps, but signs that the detached section had shifted relative to the surrounding wall. Such movement increases concern because it suggests the rock mass may already be partly unsupported. Once a fracture system reaches certain thresholds, predicting future behavior becomes increasingly uncertain. Some unstable pillars collapse during major storms. Others fail during heat waves. Earthquakes can trigger rockfalls, but many events occur without seismic activity at all. Tiny changes in internal stress may eventually produce sudden failure after years of slow movement. Yosemite's granite cliffs contain countless fractures invisible from below. Most never become immediate hazards. A smaller number evolve into unstable features requiring closures and monitoring. Royal Arches entered that category once evidence showed continued crack expansion. For climbers, the closure affected access to established routes long considered iconic within Yosemite's climbing culture. The superslide area near the fracture had drawn attention partly because climbers could directly observe the changing rock conditions up close. Unlike distant geological hazards detected only through instruments, this crack was visible. That visibility contributed to public interest surrounding the formation. Images circulated showing the widening separation line within the granite, offering a rare glimpse into the slow birth of a potential future rockfall. Yet the real scale involved remains difficult to grasp from photographs alone. The detached rock pillar is not a small loose fragment. It represents a massive granite section suspended high above the valley terrain. Even moderate movement within such a structure carries major implications for safety below. Far beneath Yosemite Valley, long before granite cliffs towered above forests and rivers, the foundations of the Sierra Nevada were forming inside a vastly different world. The landscape that now draws millions of visitors each year did not begin as exposed stone beneath open skies. It began deep underground, under crushing pressure, buried beneath ancient volcanic arcs and tectonic collisions that transformed Western North America over immense stretches of geological time. The widening fracture at Royal Arches is ultimately tied to that ancient history. To understand why Yosemite's cliffs crack, peel apart, and occasionally collapse in violent rockfalls, it becomes necessary to look far beyond the visible surface of the valley itself. The granite formations seen today are the exposed roots of an ancient mountain building system that once existed miles beneath the surface. During the Mesozoic era, roughly between 250 million and 66 million years ago, tectonic activity along the western edge of North America drove enormous geological change across what would eventually become California. An oceanic plate was sliding beneath the continent in a process known as subduction. As the descending plate sank deeper into Earth's mantle, heat and pressure generated molten material that rose upward through the crust. That magma did not erupt immediately into towering volcanoes across the region. Much of it cooled slowly underground. Slow cooling became the key. Because the magma remained insulated beneath thick layers of overlying rock, minerals inside it crystallized gradually over vast periods of time. That slow crystallization formed the coarse-grained granite that dominates Yosemite today. Quartz, feldspar, and mica locked together into massive crystalline bodies known as plutons. Over millions of years, repeated intrusions accumulated across the Sierra Nevada, creating an enormous granite batholith stretching hundreds of miles through California. Yosemite represents one exposed section of that batholith. At the time those granite bodies formed, none of the famous cliffs existed yet. El Capitan, Half Dome, Royal Arches, and Glacier Point remained buried beneath layers of older rock. The modern landscape would only emerge after immense erosion stripped away overlying material. That erosion took extraordinary spans of time. Rain, rivers, tectonic uplift, and eventually glaciers removed thousands of feet of rock above the buried granite. As pressure from overlying layers disappeared, the granite responded physically. The rock expanded slightly, creating fractures parallel to the surface. Those fractures became Yosemite's exfoliation joints. The process resembles pressure release in compressed material. Granite formed deep underground under intense confinement. Once exposed nearer the surface, it adjusted to lower pressure conditions. The resulting expansion produced curved cracking patterns throughout the cliffs. Royal Arches displays these features prominently. The broad, sweeping curves visible across the formation reflect generations of exfoliation. Layers of granite detached gradually over time, creating the rounded surfaces now associated with Yosemite's distinctive appearance. The same geological process that helped sculpt the park's beauty also produced the conditions behind modern rockfall hazards. Every exfoliation crack represents a potential weakness within the cliff face. Water enters those openings. Temperatures fluctuate. Gravity exerts constant downward force. Over time, the fractures widen until slabs or pillars separate from the main rock body. The growing crack at Royal Arches appears to be another stage within that continuing cycle. Unlike sedimentary rock, which forms in layered deposits, Yosemite's granite behaves as a massive crystalline material. Yet even solid granite contains natural fracture systems created through tectonic stress, cooling, unloading, and weathering. Many of those fractures intersect one another. Where multiple cracks meet, large blocks or pillars can become isolated from surrounding rock. Some remain stable for centuries. Others begin moving outward under gravitational stress. Once movement begins, fractures may widen progressively. This is particularly important in Yosemite because the valley's cliffs rise so steeply. In many areas, granite walls ascend nearly vertical for thousands of feet. Such steep geometry increases stress concentrations along fractures. Detached sections effectively hang above the valley floor under their own enormous weight. Royal Arches occupies one of these steep granite environments where exfoliation joints dominate the structure of the rock face. The park has spent decades studying rockfall hazards because such events represent one of Yosemite's most persistent natural dangers. Thousands of rockfalls have been documented within the park over historical time. Some were minor fragment releases. Others involve catastrophic failures of massive cliff sections. One major rockfall in Yosemite can release enough debris to bury large areas beneath shattered granite. As falling blocks strike cliffs during descent, they fragment violently. Impact energy converts solid granite into expanding debris fields composed of boulders, smaller rocks, and dust. Air pressure waves generated during large events can snap trees and scatter material far beyond the immediate fall zone. This is why closures beneath unstable cliffs are often extensive, even when the visible fracture appears localized. The hazard extends beyond the precise crack location itself. At Royal Arches, the concern centers on what may happen if the partially detached pillar loses support and collapses downslope toward trails or climbing routes below. Even relatively small increases in crack width matter because widening implies continuing displacement. Geologists monitoring unstable rock masses often focus less on absolute fracture size than on movement rates. A stable crack may remain unchanged for years. An actively widening crack suggests evolving stress conditions. In Yosemite's vertical terrain, active movement attracts immediate attention. The granite cliffs throughout the park also contain remnants of older rockfall scars that reveal how common these processes have been over geological time. Fresh scars appear lighter because newly exposed granite has not yet weathered. Older scars darken gradually through mineral oxidation and biological growth. Visitors frequently photograph these cliffs without realizing they are looking at landscapes shaped partly by repeated collapse events. Royal Arches itself likely owes much of its present form to ancient rockfalls and exfoliation failures that removed previous layers from the cliff face. In this sense, the modern crack is not an anomaly interrupting Yosemite's geology. It is Yosemite's geology continuing to operate exactly as it has for thousands of years. The difference today lies in human presence. Trails, climbing routes, roads, and visitor facilities now occupy areas beneath actively evolving granite walls. Millions of people move through the valley annually, increasing exposure to natural hazards that existed long before the park itself was established. Balancing access with safety has therefore become one of Yosemite's central management challenges. Complete elimination of rockfall danger is impossible because the valley's cliffs are inherently dynamic. Instead, officials rely on hazard mapping, monitoring systems, and temporary closures to reduce exposure where active instability is detected. Royal Arches became one of those monitored locations after evidence showed continuing fracture growth. The crack also serves as a reminder that geological time occasionally becomes visible within human time. Normally, mountain landscapes evolve too slowly for people to notice major change directly. Yosemite compresses that perception because active processes remain exposed across steep cliffs. Visitors can sometimes witness fresh talus deposits, newly scarred rock faces, or widening fractures within a single lifetime. At Royal Arches, climbers observe the cliff changing in real time. The widening crack transformed an abstract geological concept into something immediate and measurable. Granite that once appeared immovable was visibly separating apart. Yet despite the attention surrounding the fracture, the broader geological forces involved remain entirely natural. No hidden volcanic chamber beneath Yosemite is driving the movement. No mysterious seismic anomaly is splitting the cliffs apart. The processes affecting Royal Arches are the same processes that have shaped Yosemite Valley since the granite first emerged from beneath the surface: exfoliation, erosion, water infiltration, thermal expansion, freeze-thaw weathering, and gravity. Together, those forces continue reshaping one of the world's most iconic landscapes, stone by stone, fracture by fracture, cliff by cliff.